everybody. We're going to take a quick look here at some data cleaning topics, some kind of good habits to get into when you're starting a project, some of which will apply specifically to panel data. So let's take a look at some of the topics we will discuss here. Always the first thing you want to do is start a do file, start recording your commands that you find useful, both for your benefit and for other researchers who want to replicate your work. The use of the preserve and restore commands, renaming your variables so you and readers of your work can readily see what it is that you're doing. Labeling your variables, again, the same idea. You want to organize that information. Sometimes it's going to be helpful to create a macro that collects variables into a list. If you're going to use the same variables again and again, we'll take a look at that. Dealing with the problem of missing observations. How to encode a string variable so you can actually use it in analysis. And then with panel data, one of the big things is figuring out how many observations you have per entity over time. And sometimes you're going to want that to match, right? So you're going to want to have a perfectly balanced panel. We'll see an easy way to take a look at that information, and then a quick way to take a look for outliers. So let's switch over to Stata here, where I've already started without you. So the data set we're going to use for our example here is from the World Bank Open Data source. So to access this, first you have to install the WB Open Data package, so SSC install WB Open Data. And then for the example here, we're going to use what's listed as topic number 15. So these are social indicators across countries and over time. And you're going to want to use the long data format. So that's going to organize our data. So we have two columns that that together, I should say, uniquely identify each observation. So it's going to have the time and the country identifier. So it takes a few minutes. It's a fairly large data set, going back, I think, to 1961 for all countries across the world. So it'll take a minute for it to download, but go ahead and do that, and you should see something that looks like this. So we have all of these indicators across countries, regions, and years. And let's expand that out a little bit. And let's kind of imagine that we've already decided which variables we're going to want to focus in on. So we'll kind of just hone in on a few of these and then imagine that we're going to be using those for our future analysis, right? So as we mentioned, a good idea before you do anything else, right, is to start your do file editor and start recording all of the commands that you're going to find useful, right? So our first one is going to be generating the data set to begin with. And I'll go ahead and, just for the sake of example here, do that. So we just copy and paste. And then when you're following along, you would want to do this for each subsequent command. And we can toggle back over to Stata. So the next idea is we're going to be making a lot of changes to this raw data, right? And we're not always sure that these changes are going to be what we actually want to do, right? So you might want to be able to revert back to the starting point. So a good command to use at this point would be the preserve command, right? So once we hit enter here and use that preserve command, that's basically a bookmark, right? So we can make all of these changes, generate new variables, all these things. And if we want to go back to this point, we can type restore, and it'll bring the data back to its original formulation. And you can go ahead and do this multiple times, right? So once you get a point where, okay, I'm pretty sure this is going to be where I'm solid up to this point, you can hit preserve, and then you can make additional changes without the risk of losing that kind of bookmarked spot, okay? Okay, so in this case with this World Bank data, the names of the variables here are fairly clumsy, so we might want to start to rename those variables, right? So let's imagine that we have, if we kind of scroll down here, say the variable of interest here is female life expectancy, right? So that's going to be our dependent variable. So we might want to rename that variable. Bring that over here. So that's going to be our y variable. We could just rename it y, but then we'll know what it is, but other people reading our work won't know. So we might say y underscore life expectancy underscore female, something like that. A little easier to deal with, and that slots right into the same place where it was, right? And let's say we want to try to predict female life expectancy, say with 3 exogenous variables, right? And let's say, again, you would actually put a lot more thought into it, but just for the sake of our example here, where we have this literacy rate. If we pull that over a little bit more, this is a literacy rate gender parity index, right? So it's measuring within a given country at a given year, to what extent is literacy equalized across the genders, right? So let's say we're going to take that literacy rate equality index and rename that. That's going to be our x1 variable, lit rate. And let's say our, again, this is a gender equality index, primary, secondary school enrollment. So as females experience greater gender equality in literacy rates and school enrollment, do we see a gain in life expectancy? That would be the question we'd be addressing there. So we'll call this x2 underscore enrollment. And one more just for the sake of our example here. Let's take vulnerable employment percentage, and that'll be our x3 variable. So again, the format, rename the original name, space, and then your new name, employment vulnerable. Okay, so now we've got 4 variables that we're going to be using, and then a whole bunch of variables that we're not going to be using, right? So again, we've put in that preserve command, so we can do this without risk of any permanent damage, right? But we should be able to see the usefulness of getting rid of everything that we're not going to be using, right? So we could either say drop and then list all the variables that we don't want, or keep and list all the variables that we do want, right? So we're going to want all the identifying information, right? So we're going to want our country code, country name, region, region name. We'll keep these as well. We haven't used those. We're not going to use those. We definitely want our year, and then our x1, x2, x3. Just double clicking here, and then our y variable. So we're going to keep all of those, get rid of everything else. Now we've got a nice clean data set. And again, if we decided we made a mistake and want some of those variables back, we could just hit restore and get back to the beginning. Okay, so in this case, it's not a huge deal. We've only got 3 variables that are going to be on our the right-hand side of our regression, as it were. But if we had a longer list, it might be helpful to use a global or a macro to collect those into a list, right? So we can do global and create an object called xlist, right? That's going to take each of these variables, and we just list them out with just a space in between them. So we don't need to type all of those out, right? And if we want to refer to that, say we want the summary statistics, we can go $xlist, and it would be just like if we listed those out individually. And another nice thing about this naming convention, x1, x2, x3 underscore, is that creating this list, we didn't really need to do that. We could do something like this, sum x and then an asterisk, where that stands for, okay, we want Stata to call up all the variables that start with x and then have different values after that. And in this case, all the variables that start with X are the variables in our list, right? So a nice way to organize things there. Okay, now in this case, we see that the variable label column here is all filled out. So there's nice descriptions of all of our variables. That's not always going to be the case. And when there are variable labels missing or maybe incomplete, before you get too far down the road here, it's a real good idea to fill that in, right? And you can call this up with the drop-down menu. Or we can just use the label variable command. So let's say we want to change the label for our x1. So we'd go label variable our x1 underscore lit rate, and then whatever we want to throw into that variable label, the proper description of the variable, we put in quotes. Right? So we would type it in, and that's going to appear here, right? So again, you want to make sure that if it's a month from now, a year from now, next time you open up this data set or run this do file, you're going to be able to exactly replicate and understand what you did. And likewise, when you hand this over to a supervisor or to somebody evaluating your research, they're going to be able to see exactly what you're doing. Okay. Now, since this is panel data, let's go ahead and browse our data here. And like we said, this is panel data in long form, right? So we have our country identifier here in alphabetical order, so starting with Afghanistan, and then our year identifier. And we're going to need Stata to be able to identify the country identifier, right? So in this case, it's as this country code, but note that it is in red letters, right? So that means it's being it has been input as a string or a text variable, so it can't be utilized as a numerical identifier. So we need to encode that text or string into a numeric identifier, and the command there is encode. So we'll say encode, and then the variable of interest, country code, and we want to generate a whole new variable that will be numeric in nature. Let's call it code1. Okay. So what we should see now is a new variable at the bottom of the list here, and if we browse it, it's going to look exactly like the original country code. It'll be the last one here, but it's no longer in red. Okay. So now we can do something like this. We can use our XtSet command, where now we're telling Stata what those panel identifiers are, right? And they're going to be our code1, the entity or cross-sectional identifier, and year as the time identifier. And here we are from 1960 to 2019. And that wouldn't have worked with the original data. Okay, so now we're ready to go for our panel data, even though we had that string variable to start with. Okay, and now let's browse that data again. You'll notice that certainly with Afghanistan here, there's a lot of missing values, and as we scroll down, there's a lot of missing observations in every variable for every country. So what we have is somewhat of an unbalanced panel, right? So once we eliminate those missing observations, we want to be able to see, okay, how many observations are actually left, right? So it's kind of up to you the order that you might want to do this. I would probably eliminate the missing observations first, right? If these are the variables that are going to be used in our regression, any missing observation is going to be eliminated in the analysis anyway, right? So there are other commands that we could do here, but we can just say drop if, say, the value of our x1 lit rate is equal to missing. So we go equal dot, so exactly equal to a missing observation. And here we get 13,000 observations that are eliminated. We're going to do the same thing for each of our other variables. So what we'll be left with is just those rows that have numerical values for all 4 of our variables. So drop if our x3 equals dot is a missing value, and then lastly drop if our y variable is missing. Okay. So now let's do that sum command again. So let's summarize our x list and our y variable as well. And so for each one, we have 1,500 observations that are remaining. And now, in terms of that panel dimensionality, right? So a real handy variable that we might want to create here is a count variable. So how many observations are in the data set for each cross-sectional entity? In this case, how many years exist for each individual country? So we're going to use the generate command, but let's use the prefix by code 1. So we're going to break this out by our country code identifier, and then colon, and then we're going to generate a variable called count that's equal to underscore capital N. So normally, if we just did generate count equals underscore capital N, it would tell us the sample size, how many total observations are in our data set. But here, by breaking it out by country by code 1, it gives us the number of time periods per cross-sectional entity. And let's just real quick take a look at what we've just done. Always submit your data to the eyeball test, right? See what it is that we're looking at. So after all those observations were eliminated, Afghanistan was left with only 1 observation. Albania, 4 observations. 27, etc. So we have a lot of countries that don't have too many observations left. So now we might want to, we're going to have to decide, right, what's going to be our cutoff, right? So since we have a panel, if you wanted to exactly balance the panel, we would eliminate all the countries that don't have the maximum number of observations. You might want to be a little bit less stringent than that. We could do something like this. We could say, let's drop if our count variable is, say, less than or equal to 10. All right. So every country that's going to be in the remaining sample should have at least 10 time periods to get a little bit of dynamics going on in the panel, something like that. So that'll be up to you. But that's a real easy way to account for that, to control for that. Right? And we can also use now some of our panel-specific summary statistics. So if we go XtSum, and then let's say for our y variable, right, well, it gives us all the usual summary statistics, the mean, the standard deviation, the min, and the max, but it gives it in the kind of 3 available dimensions. The overall, so both time periods and across entities, and then looking at variation between entities and within entities over time. And so these observations kind of tell us the degree to which our panel is balanced or unbalanced. So T bar, so that's the average number of time periods per country, here is 24.44. The fact that that's not a whole number and it's not equal to the maximum number of time periods between 1960 and 2019 tells us that we don't have a balanced panel, but we have, again, an average of about 24 years per each country. All right, then the last thing I said we could take a look at here is looking for outliers, right? So we've kind of got already an idea here, but if we just do a summary of all of our remaining observations for our x variables and for our y variable here, again, what we're looking for with an outlier is not even a surprisingly small or large number, it would have to be a value that is basically impossible, right? Given the definition of your variable. So we're looking for coding errors, right? We're looking for something that is order of magnitude different from the mean. So for the most part, our variables here are percentages, that's our y variable, versus index numbers, the x variables. And so these are all more or less reasonable. Sorry, that vulnerable employment, that's also a percentage. These all seem reasonable based on the min and the max. You could also get the visual by using a box plot, right? So we can call that up as a graph command with the option box. And you could do this for all the variables at once and kind of do them side by side. The scale gets a little messed up there, but if we can just do it one at a time, and we've got our kind of interquartile range here, and we'd be looking for observations that would appear as little dots that are well outside those outer fences, right? Plus or minus 2 interquartile ranges, which we don't seem to see here, right? But that's what you'd be looking for. We would also want to call up all of our normal data visualization tools. We'd get our histograms, get our scatter plots. That's another video entirely. The point is, now we've got a data set that is ready to go, okay? What we should have been doing, hopefully, right, is recording all these commands in our do file. We've got it all organized. We've got the observations that we need. And now we're ready to do some analysis. So the next video after this, we'll actually do some fixed effects, random effects, panel data regression. So I will see you then. Hopefully this was helpful.